Good evening, everyone. In our last videos, we have seen very clearly how we can able to do traversals. Okay, like in order traversal, pre-order traversal, how you can able to visit the nodes in post order. Everything we covered very clearly in our last session. So even this level order traversal also I explained very clearly in our last session. Sir, if you have not understand, let me revise with one example so that you can understand very clearly. First, I will take one example. Okay, I will try to first I will explain one example. Then I am trying to create a code and then I will explain. So let us take example number one. Example number one. So what is the first example here is, suppose consider I have a root node is there like 1. For this, 2 is nothing but left subtree what we have. 2 is nothing but left subtree what we have. And 3 is nothing but right subtree for this. Okay. So 2 is nothing but left subtree and 3 is nothing but right subtree. So for this we have one more subtree is there called 4, and its right subtree will become 5. Like this I have some nodes are there. Now I need to go with in order traversal. In order, sorry, not in order, level order traversal. So level order traversal means what? In the first level, how many nodes are there? Only one. In the second node, we have two nodes are there. In the second level, we have two nodes are there. In the third level also, we have two nodes are there. So I need to explain how it is going to work. Sir, what is the first step? For this, we have to maintain a queue. For this, we have to maintain a queue. In that queue, at very beginning, you have to insert a root node. What is the root node here? 1. After that, you need to insert a null. After that, you need to insert a null. Then, so we have to write a loop to extract the data. Sir, first one, current node will become. So I am going to remove one item from the queue. Since it is a queue, which principle it is going to follow? First in, first out principle. That means the node which we inserted first will be the node which we are removing first. So the node 1 will be removed from this queue, sir. So next and after that, that will become your current node. And I will check, is that a current node? Is that a current node is null? No, it is not null. Then you have to print that. Next, so you need to check, is there any left child for this node? Yes, we have. Try to push that into the queue. Sir, is there any right node for this queue? Okay, sorry, is there any right node for this what you can call for this node 1? Yes, we have. So try to push that one also into queue. After this, what we are doing? So next we have to check, is the queue is empty? No. Try to delete one more element. Okay, sir, what is the current node that we are getting? Null. If your current node is null, then you have to transfer the control to next line. Now whatever data we are printing, that will comes in the next line. Okay, next and after that, is the queue is empty? No. Then we have to go for next one. Sir, what is the next node that we have? And one more thing, after this we have to insert null, because whenever we are getting null, we have to insert null. Now delete the next item, which will become 2. Okay, sir, is it a null? No. Then print that data. So is there any left child for this 2? Yes. What is the left child for this 2? 4. Try to insert that. Is there any right child for this 2? Yes, we have 5. Try to insert. So next, go to the next item. Next remove. Sir, next removal is nothing but 3. Is it null? No. Then try to print that. Still the control is in the same line. When the control will transfer to the next line? Whenever we are getting null. Now current node is 3. Sir, next, is there any left child for this 3? No. Is there any right child for this 3? No. Then task completed. Next, check my queue is empty. No. Then remove the next item, which will become null. So whenever we are getting null, try to transfer the control to next line and try to add that null to the ending. Now, is the queue is empty? No. Try to get one more item, 4. Sir, we have to print that 4 on the screen. Is there any left child for this? No. Is there any right child for this? No. Then go to again loop. Is my queue is empty? No. Then what we have to do? We have to perform pop operation. We have to perform pop operation. Sir, removal operation, which will become 5. Now try to print this. Sir, now for 5, do we have any left child? No. Do we have any right child? No. Then pop the next item, which will become null. So the control will move to the next line. Is queue is empty? Yes. Then break the loop, break the task. That's all. So this is nothing but level order traversal for this. Okay. I want to write code for this, sir. I want to write code for this. Of course, I'm going to take this same tree as it is. Yes, we have in order, pre-order, all these things are there. We have to take level order traversal. Okay. So level order traversal. Let us see how it will be. Okay. So what we are going to call here? So obj dot. Okay, I'm going to call obj dot. So level order. Okay, level order traversal. Okay, sir, where I'm going to pass root node. That's all. So now we have to define this level order traversal. I'm going to take so public static void level order traversal, where it is going to take one node called node. Sir, I told very clearly we need to check whether your node is equal to null. Suppose if your node is equal to null, just simply we are going to return. Otherwise, we need to maintain a queue which is going to take only nodes. So queue is equal to, so new linked list. Yes, you can take linked list also, because queue is extending properties from this also. Like this I have taken. Next, first we have to add that root node. After that we have to add null. These two compulsory we have to add. I told in the very beginning itself. Then, sir, after adding these two, what we have to do? You have to write a loop. Array, while until your queue is empty, is empty method is there in queue, which will check whether queue is empty or not. So until your queue is not empty, you have to do the task. Okay, you have to do the task. What is the task? First, try to get the node. Your current node will become, otherwise CUR I will take. Current node will become q dot. Can you please remove the first node? If your current node is equal to null, then you have to do one job. Suppose if it is not null, we have to perform some job. So if it is not null, what is your task? Try to print the data. System dot out dot print of. So your current dot data we have to print followed by space. Then you need to check your current node left is not equal to null. If it is not equal to null, try to add the term current node. Okay, that current node left field is there, right? That you have to add it to the queue. Similarly, current node right field you need to check. Is it not equal to null? Yes. So q dot add of, so current dot right we have to take. Like this we have to take. Okay. Now if current is equal to null, then what will happen? We have to print one empty line, right? We have to print one empty line. Then you need to check, is my queue is empty or not? Suppose if queue is empty, then immediately break. If queue is not empty, so q dot add of null. That's all. Very simple algorithm. So if current node, whatever first node is there in the queue, you are going to remove that node and you will check whether it is equal to null. If it is equal to null, then you need to give one empty line and then you have to check whether it is empty or not. If it is empty, break the loop. If it is not empty, then add null. Like this we have to take. Suppose if it is not equal to null, then print the data and check whether left subtree, right subtree. If nodes are there, try to add, otherwise not required. So whatever algorithm I covered here, same thing I have written in the form of code. Now let me check. Here we have uh, 1, so 2, so 3, and then 4, and then left, right, 5. Like this we have, right? So same thing we need to get. Let me check. So is the level order is working properly or not? We will cross check. Java C test.java I'm taking. Is the code compiles fine? Yes. Now let us run the code. So you can see the level order traversal is one, something is here problem. Yeah, print ln I'm taking. Now you can see here. Sir, is it coming in an order or not? Yes. Suppose if I'm taking a tree like this, okay, I have one root node, its left subtree is nothing but a 2, its right subtree is nothing but a 3, so its left subtree is nothing but a 4, its right subtree is nothing but a 5, its left subtree is a 6, its right subtree is nothing but 7. Then what output we are expecting? 1, 2, 3, and then 4, 5, 6, 7, right? Now let us check by adding these two. So root node left child, right child. For left child, we have added. So for right child, okay. So root node right child is there, right? Root node right child is there, right? So for that right, left child will become 6. Right will become 7. Sir, is it coming in the level order? Is it going to reflect in the level order? Yes, 1, 2, 3, and then in the next line 4, 5, 6, 7. Is it correct? Yes. So this is the way how we can able to extract level order traversals for the given binary tree. So same application you have to use for binary search tree also. So there I may not talk about this level order traversal. Okay, you need to convert this one. So in the binary search tree, I will concentrate on insertion, deletion, and then searching, because remaining operations will become very easy. How you have performed in this, same thing we are going to do there itself. Sir, can you please confirm, is this level order traversal, is it clear for you people? Please confirm everyone. Everyone, I request everyone to please respond. Is the concept is clear for you people? Please confirm. Right. So the next task what we have here is I want to count how many nodes are there in this binary tree. Okay, how many nodes are there in this binary tree? I want to count. Let us write a program for this purpose to write number of to count number of elements in the binary tree. Of course, in this I think I will remove pre-order. In order alone I will keep. Post order also I will remove. Okay, let it be level order, sometimes may be useful. Sir, now I want to take one more method, public static integer count nodes. Okay, I'm going to take count nodes. In your binary tree, how many nodes are there? I need to count, sir. Beyond that, nothing. Sir, here what we have to do? I'm going to print system.out.println directly here itself. I will call. What is the function? Obj dot count nodes, obj dot count nodes. So of you have to pass obj dot root link you have to pass. I think every time we have declared it as a static, right? That's why I think directly you can call binary tree by using class name. You can call how many nodes are there. Okay, how to count, sir? How to count these nodes? It is a very simple algorithm. First I will explain the algorithm. Listen carefully. Suppose consider this is the first node what I have, root node. and its left subtree is nothing but this one, and its right subtree is nothing but this one, and its left subtree is nothing but 4. Now I need to count how many nodes are there. Sir, first I will check is your node is equal to null. If your node is equal to null, then count will become 0, right? So otherwise, sir, I'm going to send, I'm going to count left nodes and then right nodes. So left node means again this one. So now again this one. Sir, whenever you are going to return, so how many left nodes are there here? 0 left nodes, 0 nodes, plus how many right nodes are there here? 0, plus this one is comes under 1. These three count we are going to take. Sir, here what will be the count? 1. That value I will return here. So here left count is 1, right count will become 0, and then current node count is nothing but 1. So we are going to get 2. That I will return here. And here left count is 0, right count is 0, current node will become 1. So result is 1. So return this one. So here left node count is 2, right node count is 1, and this node count will become 1. Total is 4. So how many nodes are there? 4 nodes, correct, right? 1 2 3 4 nodes are there. Okay, like this I am going to write. Let me document this. Sir, if your node is equal to null, then number of that count will become 0. Then integer left node I am going to take ln. I am going to call again count nodes function by passing node dot left. Integer right node count I am going to take. So where I am going to call again count nodes of right. After counting this, so we have to return left node count plus right node count plus 1. So since it is a recursive calls, so finally this pointer will reach to where, sir? This pointer is going to reach here. So now your node will become 4. So is it null? No. Left node is equal to, so it will pass its left. Its left is nothing but what? Null. Then 0 will be there. And right node, so if you pass this right pointer, then it will become null and then 0. Now I am going to return left node count plus right node count plus 1 for this node. These three I am going to call and I will return. That's all. So it is going to count how many nodes are there. In this, how many nodes are there? I think 7 nodes, right? Let me check whether we are getting that 7 as output or not. Sir, you can able to see we are getting perfectly how many nodes are there. Of course, it is very easy, right? How you can able to count the nodes. Okay, can you please confirm, is the counting operation, is this counting operation, is it clear for everyone? Is it clear for everyone? Please confirm. Okay, right, sir. Now next operation similar to this, similar to this. So next method what we are going to apply is sum of nodes. Sir, how many nodes are there? I want to count the nodes. How we can able to do this? How we can able to do this? Program is the same, right? So sum means what? We have to write, so sum of nodes. Okay, and I am going to call this a sum of nodes here also. So how you can able to check? Suppose if your root is equal to null, that is node is equal to null means 0. Otherwise I am going to calculate left sum and then right sum. Left sum will become again sum of nodes here, sum of nodes here. Then what we have to do here, in the place of 1 you need to take node dot data. That's all, right? Node dot data. Now see, I will take one tree for example purpose. Assume here I have 7 is there. Okay, and left subtree 1 is there, right subtree 2 is there, and for 1 we have left subtree as a 3 and right subtree as a 4. Like this I have. So again for 3 we have one more subtree called 5. Like this I have. Sir, what will happen? Initially node is nothing but this one, then it is not equal to null, it will call left subtree sum. So again it will call left subtree, again it will call left subtree. Here first execution, left left sum plus right sum you are going to count. Okay, so no, we are passing this one only. Now what will happen? At last 5, fifth node is going to be passed. Node is nothing but 5. Is it equal to null? No. Left sum. What is a left sum here? So left will become null. Then return 0. Plus right sum. Right node. Node is equal to null. So return 0. Plus. So what is the node dot data? This is the node. Node data is nothing but 5. That 5 will be returned here. And here anyway we don't have. So here left sum will become 5 plus right sum will become 0 plus node data is 3. That is nothing but 8. That will be returned back here. And here left sum will become 0, right sum will become 0, node is 4. So it will return. So here left sum is 8, right sum is 4 and node will become 1. Okay, so 12, 13 it is going to return. Here left sum is 13, right sum will become, so 0 plus 0 plus 2 will be returned here. So 13 plus 2 plus 7. So what will be the output? 22. 22 is nothing but total sum what we are going to get. Is it correct? So 10, 15, 20, 22. So like this it is going to work. But let me check. Of course, if you want to draw this tree, okay, I will draw better. That will be good. So root node is nothing but 7. Its left child is 1. Its right child is 2. So then left child will become 3. So left child, right child will become 4. Then root left, root right. For right subtree we don't have any left and right. So 7, 1, 2, 3, 4 and the last node we have to take. So your root is there. For root we need to take left. For that again left. For that again left will become, so new node of 5. Sir, now what answer we are expecting? 22. Let me check whether we are getting 22 or not. Yes, perfectly. It is calculating sum. For all these things, the main agenda is nothing but what? Recursion. Based on recursion only, all these things are happening. Can you please confirm this sum of nodes? How you can able to calculate? Is the concept is clear for you people, friends? So please respond. Clear up to this? Right. So the next task, what we are going to do here is height of the tree. Height of the tree. How you can able to calculate height of the tree? We will see now. Okay. Sir, what is mean by height? What is mean by height? So how many levels are there? We need to check. Based on that, we will decide height. For example, if you take any tree, for example, consider I have one is there, and here I am taking left subtree as a 2 and right subtree as a 3, and for this left subtree is a 4 and right subtree is nothing but 5. Something like this we have. Okay, we need to find out what is the height of this tree. What is the height of this tree? It is nothing but 3. Height is nothing but 3. Okay, let us see how you can able to do this. Sir, what is the first operation? We need to find out first this one will become node, and left node is there, right? It is moving to left node, so it will move to the left node. So here we need to calculate height. So what is the height of this left subtree? We don't have any left subtree, so left subtree height is 0. Okay, right subtree height is nothing but 0. So among these two, what is the maximum? 0, 0. Sir, plus this node height is what? 1. So we have to return. So here same 0 comma 0 plus this node height is nothing but 1. Sir, now left subtree height is 1, right subtree height is 1 plus 1. Among these two, what is the maximum? 1 plus 1, 2 will be returned here. So here left subtree height is 0, right subtree height is 0. Among these two, maximum and then 1. So which will become 1, that I am returning. So here left subtree height is 2, right subtree height is 1. This current node height is 1. 2 comma 1, 2 plus 1. So 3 is nothing but total height of the tree. Like you need to calculate. So left tree height will be there, right tree height will be there. Among these two, you need to take maximum. Okay, let us see how you can able to implement this, how to calculate. So I'm going to take integer height, integer height. Okay, so how you can able to write that? Public static integer height I'm taking, where I'm going to take a node, and suppose if your node is equal to null, then we have to return 0, then we have to return 0. So integer left height will become, sir, I am calling height function by passing node dot left. So integer right height is equal to, I am going to call function by using height, where node dot right I am taking. Okay, so integer my height, that means current node height will become what? So math dot max of, I am going to pass left height comma right height, these two I am taking, plus current node height is nothing but 1. So that I am going to return. Okay, I think directly we can return, no need to take any formula. So return like this I am taking. Okay, no, level, maximum level plus 1 we have to take. Height means maximum level plus 1. So this is level 0, level 1, this is level 2, level 2 plus 1. Okay, right. So this is nothing but what we have, sir. Now let us run this code. Is it working? Is it working? Maybe for this tree, the level is nothing but 4. So maybe the tree got changed. So if you want this one, 1, and then I'm going to take 2 and then 3. So, and here we have to take 4 and then, so 5. I think this one is not required. Now let us check, is it 3 is coming or not? Yes. This is the way how you can able to calculate. See, practically you can see, Vishal, this node height is nothing but 1, right? I'm not talking about edges. When you are talking about level, edges will come. So here this is at height 1. Okay, can you please tell me, everyone, is the height is 3 or 4? Sorry, is height is 3 or 2? Can you please respond? So in my theory book it is telling it is 3. Okay, we will see. As of now, try to take this, and I will conclude in the next video. Okay, how it will be, right? Sir, now I think you people got clarity about this calculation part at least. Can you please confirm, is the calculation is clear for you people? How we can able to calculate the height of the tree? Can you please confirm? Please confirm. Right. So what is the next operation that we are going to take here is search operation. I want to go for search operation. How you can able to search for an element? It is very easy, right? Just you need to check every element. Okay, just you need to check every element. Consider I want to search for the element called 2. Okay, I want to search for the element called 2. How you can able to search? So maybe here we have to send root node also. How you can able to search for node 2? Now I want to search for 6. So we know here we are going to get true because that is node 2 is there, and here we are expecting false. How you can able to do this search operation? Public static return type is boolean, and I am going to take the function name as a search, where I am going to take the node as well as integer data also I am taking. How to search? For example, if my tree is like this, 1 and then so 2 and then so 3 and then so 4 and then 5, like this we have, how you can able to search? Sir, now listen carefully. Suppose if a node is equal to null, if node is equal to null, then that element is not available, right? If your node dot data is equal to the given data, that means what? Yes, we have that element written. So if again I am going to call search function by passing node dot left comma that data. Suppose if it is returning true, directly we can return true. Okay. If I'm calling search by passing node dot right data, so comma the data what you have given. If it is true, then it is going to return true. If all these conditions are not satisfied, that element is not existed. Suppose consider I want to search for 5. This will become node. Is it null? No. Node data is equal to data? No. Then search of left node I am passing. So again, is the node is null? No. Node dot data is equal to data? No. Then again search of left. Sir, is node is equal to null? No. Node dot data is equal to data? No. Node dot left I am passing. That means null. So null. We are going to get false. Okay, we are going to get false. I think this one is going to return false, right? So if false means it won't execute. Then again one more if condition is there for right checking purpose. For 2, so it will search node dot right, that is nothing but 5. Is the data is available? Yes, then it will return true. Suppose consider I am giving 15. So here also we got a false. If false means it won't execute. So main root node we checked, and then left part we checked. In that left part, right part we checked. But for this right part is there, right? It will check now. Is your node is equal to null? No. Is the node data and your data is the same? No. So if a search operation, is there any left child? No. Of course, even it will return false. Right child return false. This task completed. This task completed. These two recursive calls also completed. Then what we have an option? False. So this node is not available. So very difficult operation, this binary search, binary tree search. But if you take binary search tree, it is easy to search because only one level direction you can able to take. That we will discuss in the next classes. Okay. So now let us check whether we are getting true and false or not. Yes, we are getting true and false. This is the way how we can able to perform search operation. Can you please confirm everyone? Sir, is the concept is clear for you people? Please confirm everyone. Is the searching operation, is it clear for everyone? Okay, right. So next I want to search for maximum element present in the tree. How you can able to check maximum element present in the tree? Let us see how to check. I think I will remove this search all these things unnecessary functions. Right. So I want to search for maximum element. Bt dot I'm going to take max element. So obj dot just you have to pass root. In this, what is the maximum element? 5 we need to get. Let us see how you can implement this function. So public static integer max element. So I'm going to pass node. Here integer maximum left pointer and right pointer, like this I'm taking. Suppose if your node is equal to null. Okay, if your node is equal to null, then I'm going to return integer dot minimum value. If your node is equal to null, then I'm going to return integer dot minimum value, last value, because we are searching for max element. Now I'm going to find max is equal to node dot data. So top level node is nothing but my data. So I'm calling left is equal to, again I will call this max element by passing node dot left. So your right variable contains, so max element by passing node dot right. Sir, then what we have to do? if your left is greater than maximum, then we have to return left. Better I will write like this. Then your max will become left. So if your right is greater than max, then your max will become right. So at last we are going to return max. Now listen carefully how it is going to work. For example, consider I have 1 is there, its left node is 2 and its right node will become 3 and its left node will become 4 and its right node will become 5, something like this we have. And here we have something like, let us consider this one as a 7 and this one as 1. Sir, first this one it is going to call. Root node is nothing but 7. So is your node is equal to null? No. Then max is equal to node dot data. Your max will become 7. Then left will become, what is the left here? Max element of node dot left. So this part again we have to call. Sir, in this is node is equal to null? No. Then here max will become 2 and left node sum is nothing but left node maximum is nothing but again we are passing node dot left. So here max will become 4 and left node max is nothing but, do you have any value? No. Then it will return minimum value, worst value. So similarly, so right node also will become, sir, is there any element here? No. Then worst value, minimum value. Among these, what is the maximum? For is left is greater than max? No. Is right is greater than max? No. Then it will return max. That is 4 will be returned here. That will be copied to left. Okay. So now what will be the right tree, right maximum value? I think it is a 5. So we are going to find out maximum. Is left is greater than this max? Yes. Then max will become 2. So is right is greater than max? Yes. Then max will become right. That means here it is going to return 5. Similarly, here we are going to get 3. So we have max is equal to 7 and left will become 5 and right will become 3. First I am checking, is left is greater than max? No. Then I am going to check, is right is greater than max? No. Then it will return max. What is the maximum value? 7. Like this it is going to work. So I think you got a clarity why I have taken minimum value. Generally, if you want to compare, okay, suppose if I want to find out whether element is there in the array or not, initially what we are taking, index value is equal to -1 I am taking, right? Because worst case in the same way, so we are finding maximum element. That's why in the integer, if you take minimum element, definitely at least one element will be there greater than this. In that point I am taking integer dot min value. I think you people got a clear clarity about this. Can you please confirm, guys, is the concept is clear for you people? Is the concept is clear for you people? Right. Now let us execute this code. In this program, we are expecting 5 as a maximum element. So now same thing I have to write for minimum element. Okay. So same thing, same code we have to write for minimum element. How you can able to write for minimum? The code is the same. Okay, the code is the same, just a small modifications. So here I am going to take minimum element which should become 1. So minimum element, minimum element, minimum element. So here also I will take a min. So min will become min, min. And here what we have to take? You need to take max value. Then you have to compare. That's all right. Now let us check. Okay, we are getting somewhere we are doing mistake. Here we should not take greater than, right? We have to take less than, because this is the maximum value in the integer. That's what we are getting. Now just replace the symbols. So now what is the minimum value in this tree? 1, sir. Minimum value in this tree is nothing but 1. Suppose if you are taking minimum value as a -5, then what will happen? sir, it is going to return minimum value as -5. Like that, it is going to work. Okay, this is the way how we can able to find out maximum and minimum value present in binary tree. But if you take binary search tree, it is very efficient. If you want to search for a minimum element, you need to visit only left subtree, because in binary search tree the elements will be arranged in a order such that, so the elements which are present in the left side of the root node will become lesser values, and the elements which are present in the right side of this node will become greater element. Like that we will have. Okay, now, so what is the next one? We have to check whether two strings, sorry, two what you can call it, two trees are equal or not. We are checking whether two trees are equal or not. We have to check. Okay, so first I will write driver code here. Let us take obj1, 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 obj1. Only three nodes I am taking. First tree. Now I am taking one more tree. One more tree. Let us take obj2, obj2 root, obj2 root left, root right. Let us take here, I am taking 4. Now I need to check whether these two trees are equal or not. So is equal method I am going to take. Is equal method I will take, where I am going to pass obj1 dot root node and another tree root node also I am going to pass. So it should return false, right? Because in this case the two nodes are say not the same. So I want to define public static boolean. Boolean I'm going to take is equal, which will take two nodes, node 1 and then node 2. We have to compare these two and then we have to take the decision. So for this, better I will remove this one. Now, so what is the next operation? First I am going to check, listen carefully. Node 1 is equal to null and node 2 is equal to null. If both are null, then yes, the answer is nothing but true. I am going to return true because both are same. Now, if node 1 is equal to null, okay, is equal to null, or node 2 is equal to null, that means if any one of the node is null, not both. If any one of the node is null, other one is not null, means then we have to return false. Okay, otherwise we have to content comparison. We have to compare content. How you can able to compare content? I am going to return which value? Sir, first we need to call is equal method by passing node 1 left child, so node 2 left child. These two are same or not. At the same time I am calling is equal method, okay, by passing node 1 right child, so comma node 2 right child. These two I am passing. Sir, left and right, if it is correct, what about the data? That data also we have to check. How to check that one? So node 1 dot data is double equal to node 2 dot data or not, I am checking. If all these conditions are satisfied, yes, your tree is equal. Now, in this case, it is going to return false because the tree is not the same. Somewhere the spelling mistake. One, two. Spelling mistakes. Sorry, guys. Sir, is these two are equal? No. Suppose if you take here also 3, what will happen? Both the trees are equal, right? Yes. I think no need to explain how it is going to work. Won't we get null pointer exception? No, that's what I'm checking here. If node 1 is null and node 2 is null, that means both the trees are not existed. In such cases, it will return true. Suppose if first tree is there, second tree is not there, or first tree is not there, second tree is there. In such cases, false. So why null pointer exception? Because we are not applying any content like node 1 dot data or node 1 dot left. Like that, if you assign, if that node is null, then you will get null pointer exception. Here there is no chance. Okay. Can you please confirm, is this equality operation? Is it clear for you people? Clear up to this? Right. So what is the next operation? Of course, last operation what we have here is nothing but copy of the tree. I want to make a duplicate copy of the tree. How you can able to do that? Now listen carefully. I will implement code for that. It is also very easy, sir. So public static node copy tree. I'm going to copy this tree. So you need to pass some node. So first I will create one temporary node. If your node is not equal to null, then so temp will become new node with node dot data, and temp dot left will become, again I am going to take a copy tree of node dot left. So temp dot right will become copy tree of node dot right. Okay, we have to return temp. Suppose if node is equal to null, then I am going to return null. That's all. So how you can able to do this? Here I am going to take obj2 is equal to, so bt dot, so copy tree of obj1 dot root. Now, so if you call obj1 dot, okay, obj1 dot, otherwise, so bt dot level order traversal of obj1 dot root node and bt dot level order traversal of obj2 dot root node. If you pass, sorry, is it static method? Yes, it is taking node. Okay. So now both answers should be same because we copied right. That's why. Sir, how you can able to do this? First, I will explain the coding. Listen carefully. I have one node is there. One, its left child is nothing but 2, and its right child is nothing but 3. Like this, I have. This is nothing but node. What we have. Okay. So first node is nothing but this one. Is it equal to null? No. Then temp is equal to new node. It will create one more node with content 1. This will become temp. So temp dot left, I am creating left by copying tree of node dot left. Sir, this is the node, right? Its left child is nothing but 2. So is that 2? Is it null? No. Create a new node with content 2 and create left subtree copy of node. Sir, its left field is null. So is node is not equal to null means it will create. Node is equal to null means return null. That means it is null. Like this it is null. Then it will become 3. Like this it is going to copy. Exactly duplicate copy. Okay. So I think how this copy operation is going to work, it is clear for you people, right? Any doubts, friends, up to this? Please confirm everyone. Is the concept is clear for you people? Right. So let's execute this and check whether both orders will be same or not. We need to cross check. Node cannot be converted to bt. It is a problem here where we are getting 69 bt dot copy tree of bt dot root obj2 is equal to new bt and obj2 dot root reference variable we have to create. Is it correct? Yes, both the trees are cloned, copied. Okay. This is the way. What are the various operations that we can able to perform on binary trees, right? I think with this binary trees concept got completed, you people got clear clarity about this one. I think you can work, explain for 3 level tree. You are talking about this copy operation. Sir, it is very simple. That much confusion is not there here. Since it is a recursion, it is very easy, sir. Okay, see here. Suppose if you have 1 here, left subtree is 2, right subtree is 2, sorry 3, and here it is 4, and here it is 5, here it is 6, here it is 7. Observe carefully, this is node n initially. Is it equal to null? No. I am creating one temporary node t with content node dot data. Then temp dot left, its left child will become, I am going to assign this left child will become, sir, node dot left. Again, I am going to perform copy tree. This tree I am going to copy. This will become node now, right? Sir, is it equal to null? No. Then create a new node. This will become temp now. Okay, temp dot left. I am going to create left node. Copy tree of node dot left. Then node dot left is nothing but what? This one I am going to send again. So it will create node dot data. That is nothing but 4. This will become temp. Then it's a left child, node dot left, null, right? It will pass with null. So if it is null, then what we are getting? Return null. Then it will become null. Got it? Yeah, right. So that's all about binary trees. So from tomorrow, we will talk about binary search trees. Okay, from tomorrow we will talk about binary search trees and how we can able to implement these what you can call algorithms on this. Okay, now after this binary search trees, we will go with AVL trees. Okay, and then something like red black trees. I will try to cover these red black trees, but it is optional. Just to keep it in mind, because I am doing some preparation work. If it is completed, I will give that. Okay, so after this we are going to talk about the graph data structure. So next and after that we have, so greedy algorithms are there, greedy algorithms, and then divide and conquer algorithms are there. Okay, divide and conquer algorithms are there. So next and after that backtracking is there, backtracking algorithms are there. Okay, so after that I'm going to cover time and space complexities. Okay, maximum these things I will take on Saturday and Sunday. Okay, probably because these are small topics, I need to explain 1 or 2 problems related to this. So these topics I will take on Saturdays and Sundays. Okay, dynamic programming also I will try to include. Okay, at least 1 problem I will try to solve. So these things I will take on extra classes. These things will be there in our regular classes. And for batch 5 o'clock batch, you have recursion topic pending is there, so that I will take on 5 o'clock in the coming next week. Okay, right, with this we can wind up, sir. Maximum I will try to finish as early as possible. Okay, right. So thank you. We will meet for the continuation tomorrow. Thank you, sir.
Thank you, sir.